Hello guys, welcome back. In this session, we will be discussing uh, your chapter number 3 of class 10th mathematics, that is pair of linear equation in two variables. Part 2. Part 1 I have already made. You can check it on my YouTube channel, and please don't forget to subscribe and like my channel. If you like my video, please do it. So this is our part 2 for the beginners. So let's start with our next topic, that is consistent and inconsistent system of pair of linear equation in two variables. So what are the consistent systems? So in our previous session we have learned that for any pair of linear equations we are having either unique solution, no solution, or many solutions, or you can say infinite solution. So any pair of linear equation in two variables, or I can say system of linear equation in two variables, if you are getting unique or infinite solution, then that pair of linear equation in two variables is called as consistent system of linear equations. Similarly, if you are getting no solution for the given pair of linear equation, and that system is called as the inconsistent system, right? So also, before we proceeding with our next concept, we already know that the linear equation, the graph of linear equation is always a straight line. So as this is our this chapter is we are discussing is a pair of straight lines, so we are getting two straight lines in the graph. So if we plot it on graph, we will get pair of straight lines, right? So our next topic is graphical representation of pair of linear equation. So how will you represent it graphically? How will you do it? First, for example, I am having a pair of linear equation in two variables, that is x plus y is equals to 10 and x minus y is equals to 4. So if I say this is our equation number 1 and this is our equation number 2, so what will we do? We will assume value of x and correspondingly find the value of y. Similarly, go for the equation number 2. So let's begin with our equation number 1. Just make one table representing the values of variables x and y. You can assume any value of x and correspondingly find the value of y. So starting with our first equation, that is x plus y is equals to 10. So say I have assumed value of x is equals to 0. So if we put x is equals to 0 in the equation, you will get value of y is 10. Similarly, in the same equation, I assume value of y is equals to 0. Okay, so what will you be the value of x? It will be equals to 10, right? So this is the way to find the solution of any linear equation. Similarly, if I say I am having equation number 2, that is equation number 2, make the same table like this and find the value of x and y at any assumed value of x or y. So if I say I have assumed the value of x is equal to 0 first, and then find the value of y, what will be the value of y? It will be a minus 4. Similarly, just assume the value of y in the second attempt, then find the value of x is equals to 4. So at y is equals to 0, value of x is 4. This is the way you can find the solution of individual linear equations. So now what is our next step? We'll plot it on the rectangular coordinate system, right? So here I am just tell you to how to draw the linear equation, but I don't have the graph, so just draw it free-handedly. So is we're drawing it on scale 2, 6, 8, 10, 12. Similarly, on the y-axis, assume 2, 4, 6, 8, 10. Right? Similarly, on the x-axis, minus 2. On the negative x-axis, minus 4, minus 6, minus 8, minus 10. And down the y-axis, that is negative y-axis, will be a minus 2, minus 4, minus 6, minus 8, minus 10. See, मैं यहाँ पे एक रफ ड्रा कर रहा हूँ. You can solve it on a graph paper as well. You can write on your own by taking one graph paper, right? So let's take the first coordinate, that is x taken as 0 and y is 10. So this is our first coordinate, right? So now what is the second coordinate? Take x is equals to 10, that is at this point, and y is equals to 0. So this is our second coordinate. So just draw it freehandedly. It will be go like this. So this is our equation of x plus y is equals to 10. Similarly, let's do it for the equation number 2. Let it take, we are having first coordinate, that is x is equals to 0 and y is minus 4. So it will be at this location. This is our first coordinate. The second equation, now x is equals to 4, y is equals to 0, and this is our second coordinate. Now let's draw the graph by joining the coordinate. This is our second straight line, that is for the equation of x minus y is equals to 4. See, the two lines are intersecting at this coordinate, right? We can say that at this point, right? So this is our point of intersection, and point of intersection is also a solution of the given system of equation. So always remember, when any pair of straight line intersect at any point, and that point is the solution of the given system of linear equation, right? So we'll write it here. I will also show you the actual representation of this pair of linear equation on the graph paper. I will show you, just wait. So if pair of linear equations intersecting at any point, then the coordinate of that point is the solution of the given system of equation, right? So please remember this concept. Okay, now this was our the actual presentation of above pair of linear equation when you plot it on the graph paper. So here you're getting the intersecting point, or this is the solution of the pair of linear equation, the coordinate, that is 7 comma 3. 3. X is equals to 7 and y is equals to 3. You can verify this by putting x is equal to 7 and y is equals to 3 in these equations. Okay, this will satisfy the equation. So these are the solution of pair of linear equation. This is the x plus y is equals to 10 when you plot it graphically, and this is x minus this the graph is x minus y is equals to 4, right? So since they are intersecting at only one point, so the given pair of linear equation is consistent with unique solution, right? This is the one way to find whether the system is consistent or having a unique solution. Okay, one more thing I will tell you. Just wait a bit. Okay, now you know that the general representation of the straight line with the coefficient is a1x plus b1y plus c1 is equals to 0, a2x plus b2y plus c2 is equals to 0. So we are having two equations, that is equation 1 and 2. So just compare it with the general equation and find a1, b1 and c1 for equation 1 and a2, b2 and c2 for equation 2. So like this is a similar way we have also done it in your polynomial. So just compare it with minus 10 because I have taken onto the right hand side, that's why I put a negative sign in front of 10. So what is the value of a1? So a1 will be 1 and b1 is also 1 and c1 will be 10, sorry minus 10, right? Similarly, if I say compare the second equation also, the second equation is x minus y minus 4. So and the value of a2, b2 and c2, a2 will be 1, b2 is minus 1 and c2 is minus 4. So this is the way to find the coefficients of the linear equations. So I generalized the concept, that is for the pair of, if the pair of given pair of linear equation is consistent, then a1 upon a2 is equals to, you can say 1 upon 1 is 1 and b1 upon b2 is 1 upon minus 1 is minus 1. You can say that, you can see clearly that a1 upon a2 is not equal to b1 upon b2. So if you can check, this is very important relation, you have to remember this, can be asked directly for your MCQs, that is for 1 mark questions, that is if a1 upon a2 is not equals to b1 upon b2, then the given system of then the given pair of system of linear equation is consistent along with the unique solution, consistent with unique solution. This you need to remember the relation. What is a1? a1 is coefficient of x for equation 1 and a2 is coefficient of x for equation 2 and b1 is coefficient of y in equation 1 and b2 is coefficient of y in equation 2. So you have to remember this. Okay, this is very important relation from the examination point of view. Now two more questions we are solving here, that is one I am having equation, that is 2x plus 3y is equals to 9 and 4x plus 6y is equals to 18. So a similar way, just find the value of x and y by taking or assumed any value of x and y. Since for equation 1 I assumed value of x is equals to minus 3, if you put the value of x minus 3 here, you will get y is 5. Similarly, if you put value of x in the first equation 0, you will get y is equals to 3. Similarly, for equation 2, that is this, if you assume the value of x is equals to 3, you will get y is equals to 1, right? Similarly, if you assume the value of x is equals to minus 6, you can take it 0 also, whatever you like. So I have taken x is equal to minus 6. Since I have put x is equal to minus 6 here, you will get y is equal to 7. You can check by your own. Now, if you draw the graph, see here, you will get only one straight line. Why? Because the given system of equation represents the same straight line, or you can say that the given pair of system of linear equation is coincident because they are overlapping each other. See here, this is our equation number second, that is 4x plus 6y is equals to 2, equation number second, and this is our equation number first. So they are overlapping with each other. Sorry, this is equation number 1. So you can say that the given pair of system of linear equation is coincident, right? And what are the solution of this equation? Anyone, please? You can say that the given pair of linear equation has infinite solutions. Constant, that means it is having a infinite solution because they are overlapping with each other, right? Also, it is consistent because these pair of system of linear equation have solution but infinite. So if you are getting this type of graph that is overlapping, then you can say that the given pair of system of linear equation have infinite with consistent with infinite solution, right? So now one more thing to remember that may be asked in your examination, that is coefficient of a1 relation with the coefficients of a1 a2 with b1 and b2, right? So it is same way where we have done it for the consistent and unique solution. So find the value of a1 and a2. a1 is 2 and a2 is 4. It is equals to 1.2. What about b1 upon b2? b1 is 3 here and b2 is 6 here. It is equals to 1.2. So what about c1 and c2? c1 upon c2. c1 we are getting, if you take it on the left hand side, it will be a minus 9, and it will be similar way, it is minus 18. So it will be 1 2. So one more relation we are arriving at, that is for given pair of linear equation in two variables, the system is consistent and having infinite solution only if a1 upon a2 is equals to b1 upon b2 or equal to c1 upon c2. This can also can directly be asked in your MCQs. Okay, so now the third kind of question is, see here, you can plot your graph, and what you are getting by assuming any value of x and y, you will getting the graph of equation 1. That is, equation 1 is x plus 2y is equals to, oh sorry, minus 4 is equals to 0. This is the graph. And what about graph for equation second, that is 2x plus 4y minus 12? It is like this. So you can see from the graph are is non-intersecting because they are not intersect any at any point because these are parallel to each other, right? That means the given pair of linear equation has no solution. No solution means the given pair of system is inconsistent. This is the inconsistent pair of linear equation, right? This has to be remembered for your examination point of view. This is very important also. So since they are parallel to each other, so they are having no solution. So find the relationship with the coefficients also, that is a1 upon a2, b1 upon b2 and c1 upon c2. So I'm writing it here. This a1 upon a2 is equals to, you can say, is 1 and b is a2 is 2. Similarly b1 upon b1 is 2 and b2 is 4. Similarly c1 upon c2 will be minus 4 upon minus 12, it is 1.3. So in case if you got a1 upon a2 is equals to b1 upon b2 but not equal to c1 upon c2, then that pair of linear equation is inconsistent and you can say having no solution, right? So today's session is very important from your examination point of view. We have discussed various problems, graphical problems, as well as questions that can be asked for your 1 marks in the MCQ. I think if you like this video, please don't forget to subscribe and like my channel.